Welcome to Chapter 13 on water resources. Will we have enough usable water? Well, first, how much do you think of the Earth's surface is covered with water? Do you remember when we threw around the ball the other day, the little ball of the globe, and every time your thumb hit the water, we made a tally. So after doing that over and over and over again and tallying, you should see that roughly 70%, 71 to be a little bit more accurate, is covered with water. But as we also remember from the activity, majority of that water was found in oceans, so it was saline. So how much of this water is fresh water? Only 2.5%, because 97.5% of the earth, the water that's covering the earth, is salt water. So of the fresh water, so of that 2.5%, how much is tied up in ice and glaciers? So 77.28% of that 2.5% is tied up in glaciers. So a total of 1.9% of all the Earth's water is frozen. So out of the Earth's water, less than 1% is accessible for human use. So the way it's usually divvied out is that 0.55% is groundwater, and we'll talk about what groundwater is again in a minute. 0.01% is in surface water, and then 0.001% is in water vapor in the atmosphere. We manage our water poorly. We have a hydraulic cycle, which y'all know about because I showed y'all that picture of that my daughter drew of the water cycle in first grade. So y'all know about the hydrologic cycle, also called the water cycle. And the major forces for purification are evaporation and infiltration. So if we don't overload the water process, it cycles itself and it purifies it for us. It's one of the pieces and components of natural capital that we get. So evaporation, when molecules heat up, they get less dense and therefore they become less dense than air, so they will kind of float up. And then as they cool off into as it cools off into the atmosphere, gets into the troposphere higher up, then it condensates and it falls back down again. Usually that process gives us a little bit more of a cleaner water. Problem is that we have a lot of rain now falling as acid rain because of the components and particulates and some of the pollution that's found in the air now. Infiltration, that's the process that the water will trickle down through the rock, and when it does that, the rocks purify the water for us as well. Again, as infiltration percolation. So basically the water is trickling down, like I was saying, and it lands into the groundwater where it hits an aquifer. And as it does this, the aquifers are usually very, very low DO and very, very cold, which is not ideal conditions for bacteria. Therefore, it's usually pretty pure for us. And so the process of the water trickling through the rock to get down to the aquifer kind of basically creates a filter for us. Another way we see it, I wrote evaporation on here, but it's also, I usually call it evapotranspiration, because really what's happening too is that your water is getting purified by the plants. The plants uptake water through their roots, and then the water is through the transpiration process, through cellular respiration pretty much. Water ends up under the stomata of the leaves, and during the day, remember in the morning, you'll go outside and all of a sudden it seems like, did it rain or did it not rain? Well, the dew on the ground that you see, or on the grass and all the other plants, is simply the transpiration or cellular respiration process of plants. And so then during the day, when it heats up, those water molecules are pure and they're going into the air for us. So that's the major way that water is purified. But unfortunately, like I was saying, when it hits the atmosphere, and it's definitely collecting particulates, and the particulates are having a chemical reaction, and the gases. So it's not just particulates, it's also the toxic gases. We'll talk a lot more about water pollution later on in the spring, though. But nonetheless, if we can not put as much toxins into the environment, then the nature will purify it for us. And if we don't destroy the wetlands and forests, then nature will also be able to clean it for us. Wetlands are the Spartina grass down at Skidaway. They're amazing because it filters out the toxins, because the base of the river, the river basins, if you will, they all dump into pretty much estuarine environments where the river meets the ocean. And so it's kind of unique environment and unique habitat because you have all kinds of varying temperatures and salinity during the day. But also the Spartina grass is going to help siphon out some of the toxins before it lands into the ocean. A lot of studies have been done on the Spartina grass and a lot of the other filter feeders, clams, etc., that live down in these wetlands. But what's really cool is they've done studies where they take a piece of grass and they'll dissect it and use stereoscopes and chemical analysis just to get an idea of what kind of pollutants are coming down. So we know that the Spartina grass and all the different other flora are helping to purify the water for us in those wetlands. Okay, problems with water. Water is not distributed evenly. You have some areas basically that have a lot of water yet have small populations like Canada, and then you have areas like China where you have an abundant world population, abundant supply of people, but not an abundant supply of water. And it doesn't say on here, but Asia's got 60% of the world's population and only 30% of the water supply. So that's significant because a lot of countries will end up fighting over water and the people who have water versus don't have water. Turns out we are managing our water poorly. We take too much too fast. If you pull out too much too quickly, that means you're going to deplete the groundwater source and the aquifers that we have. And on the next slide, I'll tell you what those are. But the water we do have, we pollute it and we don't take care of it, and the problems when the groundwater gets polluted is that it's very difficult to clean because groundwater, as you'll see on the next slide or two, moves at a very, very slow rate, about a meter per year, and it's very difficult with the low DO. So when you don't have bacteria to help break down materials, then it's difficult to clean up the pollution. Some global water issues. Access to water is a global health issue. It's an economic issue, a women and children's issue, and a national and global security issue. Turns out that so your book was telling you that in 2007 they did a statistical analysis in the who is a World Health Organization. I can never say that, but they had estimated that more than 1.6 million people basically did not have access to clean drinking water, and about 1.6 million people, 90% of them children under the age of 5, would die from preventable waterborne diseases such as diarrhea, typhoid fever, and hepatitis. Well, I went online today and looked at the World Health Organization to see how it was going now. Your book, by the way, was published in 2007, so a lot of the statistics here are going to be out of date. They're still relevant because they're going to be close, because a lot of statistics take years it's lagging data anyway. But anyway, so now it's up to 2 million. They say that 2 million people a year die, and it has to do with these waterborne diseases. And what happens basically, if you're healthy anyway, then you'd probably get sick. Like if you drank water that had giardia in it, you'd have a severe stomach cramping, diarrhea, throwing up, vomiting, you feel crummy for several days. But eventually, your body has a strong enough immune system and enough nutrients in it that you could probably survive it. But these children who are already malnourished in developing countries, they don't have that. They're already malnourished anyway, and so these children under the age of 5 are the ones that are primarily dying from preventable waterborne diseases. It's an economic issue also because basically you have to have water. Water is vital for reducing poverty, and you have to have water to produce food and energy. It's also a women and children's issue because in a lot of your developing countries, they're the ones that are charged with the task of bringing the water back to the community for everybody else to drink. And then you have national and global security issues because the tensions within and between nations over access to limited water, especially in the Middle East and then other areas of the world. And even in the state of Georgia. So we've been having ongoing litigation with Florida and Alabama over our damming of Lake Lanier. We had permission to dam Lake Lanier for hydroelectric power, but we did not have permission to use it as our drinking water. So we continuously are in litigation about that. A lot of the proponents, I guess on our side here in Georgia by Lake Lanier say, well, we actually recharge the lake, but because when we clean our sewage, we put the clean water back into Lake Lanier. So majority of it is cycling back into the lake. So that's the primary counter to the water litigation that's going on right now. This is a girl carrying well water over dried out earth during a severe drought in India. This is a website that I wanted to share with you. Water is Life. This is a nonprofit organization. They go on trips and they take materials and help with drilling and creating underground, basically tapping into the groundwater systems and developing areas. And so I really like the site. I've contacted them to see what kind of fundraising we can do to help with their project. But this is pretty amazing. Kind of shows you some chemical engineering and ingenuity that we can do to help solve some of these crises. Like I said, the people dying are majority children under the age of 5. So hopefully this will kind of strike home to you. Let's see, which one do I want to show you first? Let's see the I also wanted to share with you, that was pretty cool, wasn't it? Also want to show you their homepage of their website so you can see what else they're doing. This right here is an example of a life straw. Basically, it's a water purifier. And this is their homepage, their website. I like this over here. A 4-year-old shouldn't need a bucket list, and 1 in 5 children under the age of 5 die each day from a waterborne disease. And here's where they show where to access their information and where you can go to donate. I thought it'd be cool for us as a environmental science class to perhaps use some of the media that they have available in order for us to maybe set up camp out in the cafeteria and do a fundraising drive for this. And what was really cool is they have some things that I can print out for us to use in order to, so I thought this was cool, like a 3x5 card to show how donations can be made in order to give water, clean drinking water. I just thought this was pretty stinking cool. Okay, so here's the life straw. $10 equals 1 straw. But down here, I thought this was super cool, so we could educate people on how these suckers actually work. And it's very similar to how filters work at the water system plants. The charcoal filter here has water passes through the final charcoal grates, removing any bad taste and providing fresh, safe water. It starts down here though. Membrane filters. The straw hits the water. The first chamber filters particles, membranes, and molecules. Next, water passes through iodine filtration, and then you have your charcoal filter last. I just thought this was a super, super duper cool a visual that we can perhaps print out so we can try to do something to join and help out the cause. I'm passionate about clean water for all. Okay, so back here.